Hey everyone, welcome to the show. I am really excited about today's episode because we are talking about something that basically runs the internet, cloud computing.
Yeah, and especially we are going to break down two ideas and that sound very technical, but the actually super simple ones. You get the concept. We are talking about cloud elasticity and then resource provisioning and allocation.
Exactly. And look, we are going to explain like we are explaining it to a friend over chai, okay?
Love it. So let's start with elasticity. You know how a rubber band works.
You stretch it when you need to cover something big and it a snap back when you don't.
That is literary cloud elasticity.
Done? Okay, we need to deeper than that, but that's the script of it, right?
So let's talk properly. Cloud elasticity is the ability of a cloud system to automatically increase or decrease its computing power based on how much work it needs to do at any given moment.
And when we say computing power, we may mean think like CPU, the processing brain RAM, the working memory storage and network bandwidth.
Now here where it's get interesting. There are two ways to scale. First, vertical scaling, also called as scaling up. That's when you give the same machine more power. Think of it like upgrading your laptop from 8 GB RAM to 32 GB RAM.
More muscles, same machine, same address, same building, just a bigger apartment inside.
Exactly, and then there horizontal scaling out there when instead of making one server storage, you add more server to share the load.
Perfectly analog. And the magic of the cloud is that it can do both of these things automatically without any humans sitting there clicking buttons.
Perfectly analogy, and the magic of the cloud is that it can do both of these things automatically without any humans sitting there clicking buttons.
Like instead of making one cashier work faster at a supermarket, you open 5 more checkout lines.
Perfect analogy, and the magic of the cloud is that it can do both of these things automatically without any humans sitting there clicking buttons.
That automatic part is called as auto-scaling. The cloud watching your traffic like a hawk, and the moment it see up speak, boom, it spin up new servers.
Let me give you a real example. Think about Netflix. On a normal Tuesday afternoon, maybe a million people are streaming. Netflix doesn't need many servers.
But at 9 p.m. on a Friday, maybe 50 millions people hit play at a same time without elasticity, and the whole thing crashes.
But because Netflix uses AWS, their cloud infrastructure stretches automatically. More views comes, more servers appear like magic.
And then at 3 a.m. when nobody watching, those extra servers show down. Netflix doesn't pay for them anymore.
That's the other beautiful things about elasticity. It saves money. You pay only for what you use. It's like paying for elasticity. You don't pay for the elasticity for all the bulbs in our house all day. You pay only when you turn them on.
And this is completely different from how business used to work before the cloud. Before cloud, if you are you were a company and you expected your website to get a million visitors, you had to buy physical servers. That cloud handle a million visitors.
Even if most days you only get 1 lakh visitors.
So you are paying for a millions visitor setups every single day. Even when you are only serves 100,000 people, that's just burning money.
Companies used to buy hardware just in case of a peak demand, and then what that hardware sat doing nothing 95% of the time.
Cloud elasticity killed that problem. Now you scale to exactly what you need when you need it.
Yes, another amazing example, Zoom during COVID in 2020. In February 2020, Zoom had about 10 million daily users. By April 2020, that jumped to 300 millions.
300 millions into 2 months. That's 3x increases.
And Zoom did not crash. They did not have to scramble to buy new hardware because their cloud infrastructure just scratched.
Elasticity like a rubber band.
Elastic like a rubber band, and the technical way this works in through something called the auto scaling group and load balance. The load balance sits in front of all servers, distributors, incoming requests evenly.
And the auto scaling group has rule like a CPU uses goes above 70% of 5 minutes and 2 more servers.
And if CPU drops below 30% for 10 minutes, remove 2 servers. It's all rule based and automatic.
So the sum up elasticity, it's the elasticity ability to grow and shrink based on demand automatically. So you are always performing well and never overpaying.
Next part is a transaction. Now let's talk about the behind the scene operation that makes elasticity possible and honestly makes the entire cloud work. Their resource provisioning and allocation.
These two words sound very corporate and boring.
They do, but think about in this way. Provisioning is getting the resource ready and allocation is deciding who gets what.
Like provisioning is the chief cooking the food and the allocation is the waiter deciding which table gets which dish.
Exactly, you need both. If the chief doesn't cook, there are nothing to serve. If the waiter doesn't allocate properly, people get the wrong food.
Okay, so let's start with the provisioning. Resource provisioning is a cloud computing means sitting up and preparing the IT infrastructure that users and application needs.
This includes virtual machine storage, database, networking. Everything makes a cloud environment work.
And there are three main models of provisioning. The first one is a manual provisioning.
Manual provisioning is exactly what it sounds like. A human administrator goes in and manually sets everything up. They decide, okay, this server gets 4 CPU, 16 GB RAM and 200 GB storage.
This was very common in the early days of IT. Everything was hands-on.
The upside is that you have a complete control. You know exactly what's been set up and how.
The downside is it's slow. If you need 100 server, someone has to configure 100 servers one by one. That cloud take days.
Then came automatic provisioning. This is where script and tools do the work for you. You write a script once that say create a server with this space, and you can run it 1,000 times.
Tools like Terraform, AWS Cloud Formation. This let engineers write what's called infrastructure as a code. Your entire infrastructure is described in a text file.
Which means you can version control it, share it, repeat it, and delay it anywhere. If something breaks, you can just run and script again and rebuild everything from scratch in a minute.
This changed the game completely. Suddenly, a team of 3 engineers cloud managed thousands of servers because they were not configuring them manually.
And then the third model is a self-service provisioning. This is what most of us actually experience. You got the AWS console or Microsoft Azure portal or Google Cloud, and you just click a few buttons.
It's like ordering food on swings. You pick what you want and you click order, yeah, and it appears. You don't need to know how the kitchen works.
This democratized cloud computing massively. Before you need a whole IT team to set up infrastructure. Now a solo developer can spin up a global application in an afternoon.
Okay, so that's provisioning. Getting the resource ready. Now let's talk about the allocation. Allocation is deciding how those resources are distributed or assigning.
And again, there are two main types: static allocation and dynamic allocation.
Static allocation means fixed resources. You say this server is dedicated to this application. Periods, full stop. It doesn't change.
Think of dedicated servers for a bank. The bank rent a server. They own that server's full resources. Nobody else uses it. It's predictable, secure, and stable.
The downside, if that bank system only uses 30% of the server's capacity most of the time, 70% is just sitting there wasted.
Dynamic allocation is the opposite. Resource shift based on real-time needs and properties. If applications A is ideal and application B suddenly needs more CPU, the system can take resources from A and give them to B.
This is much more efficient but also more complex to manage.
Kubernetes is a great example of a dynamic allocation. It's an open source system that manages containers, which are small, lightweight virtual environments, and it constantly watches resource uses and distributes capacity to whoever needs it more.
It's like a very smart traffic controller that knows where the connection is and keep cars to keep everything moving.
Now here's something important. There are three states you can be when it comes to provisioning and allocation, and two of them are bad.
The three states are over provision, under provision, and right sides.
Over provisioning means you have allocated more resources than you actually need. You have got 16 CPUs for an app that only ever uses 2.
Your app runs fine, but you are paying for 14 CPUs that are just chilling, doing nothing, waste of money.
Under provisioning is the opposite. You have allocated 2 liters. Your app is trying to run, but it doesn't have enough resources.
Slow performance, crashes, timeout, users are frustrated.
Right sizing means you have found a sweet spot. Just enough resource to run efficiently with a little buffer for spike.
And the cloud make a right size much more achieved because you can monitor usage in real time and adjust.
There are tools like AWS Computer Optimizer or Google Cloud recommendation engine that literally watch your resource uses for weeks and then say, hey, you are using a machine that's twice as big as you need.
Free money basically.
Not free, but saved money, which feels just as good.
There also something called a SLA, so means server level agreement, and QoS, quality of server. There are basically promises. A cloud provider says we guarantee 99% of uptime. That means your servers will be down for no more than about 52 minutes in an entire year.
And To keep that promise, the cloud provider has to ensure that your allocated resources are always available and performance at the required level. If they mess up provisioning or allocation, they break the SLA.
And breaking an SLA has financial penalties. So cloud providers are extremely serious about getting provisioning and allocation right.
Okay, so we talk about both topics separately, but let's connect them because they are deeply related.
Cloud elasticity is impossible without proper provisioning and allocation. You can't stretch dynamically if you haven't already built the system to provision resource quickly.
Exactly. When auto scaling says add two more servers, so what's actually happening is a provisioning process. A new virtual machine is being created, configured, and allocated to your application servers group under a minute.
The reason it's that fast is because cloud providers like Amazon and Google have built a massive automated provisioning pipeline. They have pre-built the infrastructure. When you click launch an instance, they running highly optimized script that's been run millions of times.
And allocation happens in a real time behind the scene. The hypervisor, the software that manages virtual machines, is constantly allocating CPU cycles, memory pages, and network bandwidth among hundreds of virtual machines running on the same physical hardware.
So elasticity is the visible result. Your app scale up and down. Provisioning and allocation are the engine underneath making them happen.
Alright, let's land this plane. What are the key things we want everyone to talk away with today?
Number 1, cloud elasticity means your infrastructure can grow and shrink automatically based on demand. You only pay for what you use and you never have to worry about running out of capacity.
Second, there are two ways to scale vertically, meaning more power to the same machines, and horizontally means more machines to share the load.
And third one is the resource provisioning is how you set up cloud resources. It can be manually automated or self-services, and automation is the modern standard.
Fourth one is the resource allocation is how you distributed these resources. Static means fixed assignment. Dynamics means flexible real-time redistribution.
And number 5 is the always aim for a right size. Over provisioning waste money, under provisioning destroy performance.
The cloud took what used to require a team of 50 IT engineers and a warehouse full of the servers and turned it into something and developers can set up in 15 minutes from their laptops.
That's the power of elasticity and smart provisioning. It's not just a tech thing, it's an economic